Guys, welcome back. Today what we're going to be talking about is solution concentration. And the unit that we're going to be working with is known as molarity. Molarity is probably the most common way to represent solution concentration in chemistry. And we define molarity as the number of moles of solute that are dissolved per liter of solution. Molarity, again, a unit of concentration that can be defined by the number of moles of solute dissolved per liter of solution. Molarity is represented with the capital letter M, so we could say M equals moles per liter. You just have to remember that the mole is referring to the moles of solute, and the L, careful here, isn't referring to the liters of water that you add, but it's referring to the whole volume of the solution once the solute is dissolved into it. So let's say you had 1.0 moles of sodium chloride and you dissolved it in some water until the final solution volume was 1.0 liter. What is the concentration then in terms of the molarity of this solution? You just divide the numbers out. That's easy enough. It gives us 1.0. And then you'll know the units would come out to be moles per liter. But, like our equation up above says, moles per liter is actually molarity. So the way that we actually are going to write it is we're going to write it as 1.0 molar sodium chloride. You notice the way that I pronounce that when I have the M in the actual concentration there? It's 1.0 molar sodium chloride. And you can work with any quantity of moles or any volume and still calculate the molarity. If you had 0.50 moles of sodium chloride and you dissolved it in some water until you had a total volume of 0.25 liters of the entire solution, we'll do the same thing by dividing our numbers, and this time what we're going to end up with is a 2.0 molar sodium chloride solution. Again, all you need is the moles and the liters and divide them, and then you've got the molarity of the solution. Now in chemistry, however, when we're actually working in the lab, we can't measure things out in moles, and we typically don't work with buckets and buckets and buckets of solution. We only work with smaller quantities than that. So what we're going to be needed to think about is if we work in the lab with gram quantities and we work in the lab with milliliter quantities, how could we determine what the molarity of a solution is? So again, if we have 10 grams of sodium chloride and we take that 10 grams and we dissolve it into a solution until the final volume is 100 milliliters, what concentration in terms of molarity of solution did we make? Again, molarity is moles per liter. We didn't give you moles or liters, but we gave you enough information to get that information. Remember how to convert grams to moles? So we'll take our 10 grams of sodium chloride. Need to go to the periodic table to get the molar mass. It turns out it's 58.44 grams sodium chloride are in 1 mole of sodium chloride. So when you convert your 10 grams of sodium chloride to moles, you end up with 0.171 moles. Now be careful, remember your sig figs. If your mass quantity has 3 sig figs, once you convert it to moles, it has to maintain those 3 sig figs. And again, molarity moles per liter. Now we have our moles. Now we need to figure out how many liters we have. Easy enough to convert milliliters into liters. You just need to bounce your decimal point over 3 places to the left. So your 100.0 milliliters is 0.1000 liters. Careful with those sig figs. 100.0 has 4 sig figs, so once you convert it, you need 4 sig figs. So make sure you have that final 0 there as well once you convert it. Now you've got your moles, you've got your liters. Now you use your molarity equation to solve for the concentration. So you'll take your 0.171 moles of sodium chloride, divide it by the 0.1000 liters, and what you've actually made when you've dissolved 10.0 grams of sodium chloride to a total volume of 100.0 milliliters, you have made yourself a 1.71 molar sodium chloride solution. Another way we use molarity in the lab is, let's say that you were doing a lab and for whatever reason you needed 0.038 moles of copper 2 chloride. Again, what you could do is you could convert that into grams and you could go mass it out on a balance, and then you would have that number of moles. Well, if we didn't have any solid copper 2 chloride, what if we had a 0.50 copper 2 chloride solution? Okay? Again, what that means is I have 0.5 moles of copper 2 chloride dissolved per liter of solution. You know what? Let's squeeze another 0 in there. Okay? So what volume of that copper 2 chloride solution would you need to take to make sure that you had 0.038 moles? Well, you can use the molarity equation to easily figure that out. Molarity is moles per liter. Well, the molarity of the solution is 0.50 molar. The number of moles we said we wanted was 0.038 moles. And again, what we want to know is how many liters of solution would that be? So we do some algebra, we solve for x, and it turns out we need 0.076 liters of our 0.50 molar copper 2 chloride solution, which is 76 milliliters. So again, if we take 76 milliliters of our 0.50 molar copper 2 chloride solution, we will have 0.038 moles of it. Another way that sometimes people do the math to figure out what volume of solution they need is they do it in a T-chart way. So this is just another way of solving that same problem. You could take your 0.038 moles, which is your given, and then again in a T-chart you want to make sure that moles is on the bottom, and if you're solving for liters that would be on the top, and so our concentration 0.50 moles in 1 liter. And then what you end up with again is 0.076 liters. All right, that's just two different examples of what you can do with the molarity equation, and you're going to have an opportunity to work on more problems in class. But the next thing that I need you to do is I need you to make sure that you understand how you actually go about making a solution in the lab. It's pretty complicated. You don't just dump your solute into water and kind of get approximately the amount of solution. And so what I'd like you to do is I'd like you to go to this YouTube site right here. And I'd like you to go there and I'd like you to watch this really cool guy making a solution. Mitch, sorry, it's not Roald Hoffman, but you know what? He's a cool enough guy and you're really going to learn a lot about how to make a solution. So go ahead, type that into your browser, watch it, and learn. See ya!